Greetings to all. Uh, Today, my name is Santosh from second CSC. Today, my topic is test sequence. In that, a sample 26 bulbs gives a mean life of 990 hours with a standard deviation of 20 hours. The manufacturer claims that the mean life of bulbs in 1000 hours. Test the sample not up to the standard. Here, the problem is from 50 unit. It is a problem statics. Let me discuss how the problems is going, how it is useful in our life. Let it be explained in depth. After that, a sample bulb of 26 gives a mean life of 990 hours with a standard deviation 20 hours. The manufacturer claims that mean life bulbs is 1000 hours. Here, not up to standard. It we have to understand that 26 bulbs are given in time of 990 hours with the standard deviation 20 hours. With mean climbing 1000 hours. We have to compare the 26 bulbs have in that what is the degree of freedom and what is the techniques, what are the methods we have to use in it. It is a test significance. It is used for small samples. There are some important test samples like student t-test and F test and psi test, psi square. Sorry. Here in that we discuss completed about student t-test and we later we discuss about F test and psi square. A student test is a statistical used to compare the mean of two groups and determine if the difference of statistical significance due to random chances. It explains useful when sample size is small in less than 30. Population standards and unknown or we are known. Data is approximately normal distributed. After that, here types of students test one sample or independent two samples are paid sample t test. We discuss clearly here used to compare the sample mean with known population mean, and another one is compare meaning two independent groups, male or female. Some examples. Here, in case we comparing, in case there is known or unknown, in a pair test it means same group at different times. After that, mean life of birth. It explains about how testing is going on, how properties, how it will be implemented. There is no sequence difference between groups. It is called null hypothesis. If any significant state is occurred, in case the H0 mu1 is equal to mu2, in group case they are equal. And H1, it is not equal. Both are not equal. Next, standard deviation analysis. How standard deviation it based on how it implies how the formula is used. Here x minus mu by s square by n, square root of s square by n, where x is sample mean, mu is population mean, s is sample standard deviation, n is degree of freedom. Let's be testing the our problem in 5 cases. In null hypotheses are given or not, all alternate hypotheses and gain of significance or test statistics and conclusion. By the 5 methods, we conclude that our problem, our question or our problem is null hypothesis, whether it satisfies or rejects. We finally conclude whether it is useful for null hypothesis or not. Like given problem, there is given sample size n 26 and mean is 990 hours and SD is 20 hours. Population means 1000 hours. Here they given sample data, whatever they given, we simply understanding what size is 26, mean is 990, standard deviation is 20. By the degree of freedom, formula is n minus 1. There is a size is 26. We subtracting 1, 26 minus 1, 25. Here, frequent every problem or every question, we have to take 5% of level of significance, 0.05. After that, null hypothesis mu is equals to 1000. Here, mu not equals to 1000 because of alternate. Alternate hypothesis is not equals to both are not equal. In case in null hypothesis, mu is equal to 1000. Loss of significance is equal to 0.05. Here we substituting or it is modulus. In case any negative values are common, it by defaultly it shows mm, positive only. In case it is for example x modulus is referred as clearly, piecewise, x plus when is goes to x, when minus x is equals to x. This is the property of modulus x. In case we are taking variable, it changes into t. If any negative value comes, it takes only positive x. Here, 990 x bar, 1000 divided by 20 divided by square root of 25. 25 is 5. 5 by 20 by 4. 4. 4 divided by some 990, 110. After that, conclusion. We conclude that finally T alpha is a similarly line of significance divided by 2. It comes 0.025. By comparing table, we conclude that 2.06 by uh, drawing a graph. Here our condition is anytime modulus T less than T alpha. T alpha refers a loss of significance. When they accept condition, when they occur less than T alpha, then only we accept the null hypothesis. But in this case, T modulus T greater than T alpha because of the value is 2.25. Here value is 2.06. It is too high. 2.5. It means 2.50. It is 2.06. Absolutely, T alpha modulus T is greater. That's why we reject the null hypothesis. We conclude that we compare calculated T values by critical T values. If the calculated value exceeds the critical, will reject the null hypothesis we discussed about. The result of incidence whether manufacturer claims is supported by the data. After that, implication finding. If any rejections are occurred, any samples, any sample bulbs are occurred, we are consuming how the marking is going. In future research direction, further studies, we larger samples are can be enhance reliability. Investing other factors affecting bulb supply may be provide comprehensive insights. Continue monitoring for bulbs performance will ensure quality standards. Thank you, giving golden opportunity.